Hello student, myself Jiten Kumar. I am going to teach you chapter number 2nd. It is from class 9th and chapter is Force and Law of Motion. On the basis of this chapter, we take here the numerical values. We solve these values. You understand, you watch this type of question and understand them. Question number first is given here. It is from a rifle of mass 4 kilogram. A bullet of mass 50 gram is fired with an initial velocity of 35 meter per second. Calculate the initial recoil velocity of the rifle. We consider here the mass M1, mass of rifle M1 is equal to 4 kg, and mass of bullet M2 is equal to 50 gram. We convert it into kilogram, it will be 0.05 kilogram. When we divide 50 gram by 1000, it will be 0.05 kilogram. And given with the initial velocity of 5 meter per second. We consider the velocity of the rifle will be recall the velocity of the rifle. We consider the initial velocity, the recoil velocity of rifle V1 is equal to 35 meter per second. And it is V1 is equal to, we find our recoil velocity of rifle we have to find. So it will be what? And V2 equal given 35 meter per second. In the rest position, when the rifle is not fired, it is in the rest position both rifle and bullet. When we do not fire the rifle and bullet both will be in rest position. So we take the velocity of rifle and bullet 0. So this type of question we solve that on the basis of momentum. So we write here total momentum before fire is equal to total momentum after fire. We write here M1 plus M2 into V is equal to M1 V1 plus M2 V2. Because in the rest position before the fire, the bullet and gun is in rest position, so we take the velocity, in the rest velocity will be 0. So we write M1 plus M2 into 0. M1 mass of gun is 4 kilogram into V1. We have to find out the recoil velocity of the rifle, it is V1 plus M2. Mass of bullet is 0.05 kilogram and Vp is given 35 meter per second. When we multiplied m1 plus m2, the total mass of the rifle and bullet multiplied by 0, it will be 0. So we write here 0 equal to 4v1 plus 0.05 into 35. We have to find v1 is equal to 4v1 equal to, when we take the 0.05 and into 35 in another, transfer it in the other direction, other side, it will be negative because it is in positive. When we took it from other side, it will be negative, minus 0.05 into 335. v1 is equal to 0.05 into 35 upon 4. We multiplied or cut here minus 5 5 the 25, carry 2, 5 3 is 15 or 2 17. We put decimal 1 2 two places, it will be 1.75 upon 4. When we divide it, v1 is equal to 0. We divide 17, 4 4 is 16, carry 1, we take here 5, it will be 15, 4 3 is 12, remainder is 3, we take another 0, it will be 30, 4 7 is 38, remainder 2, and again we put 0, it will be 20, 4 5 is 20. It is meter per second. So it is our solution of the question. The total momentum before fire and total momentum after fire is equal because initially when fire is not done, the bullet and gun together, and total mass of the bullet and gun take together, and velocity is 0, hence the total momentum before fire is 0, and after total momentum after fire is, we look here, we can look here, m1 v1 plus m2 v2, because it is the mass of bullet, mass of gun, and v1 is the mass velocity of gun. It is, we have to find. In second position, the mass of bullet into mass velocity of the bullet, and we multiply 4 by v1 equal to 4v1 plus 0.8, we write same here, and this type we solve the question. Next question number second is, question number second is saying this: two objects of mass 100 gram, two objects of mass 100 gram and 20 gram, 200 gram are moving along the same line. Two objects, it mass 100 gram and it's 200 gram. Moving along the same line. These are moving along the same line and direction and same direction. With the velocities of v1 is equal to 2 meter per second and v2 equal to 1 meter per second respectively. They collide, and after collision, the first object moves at the velocity of 1.67 meter per second. Determine the velocity of the second object. This is the same question on the basis of first question. We write total momentum before collision. Total momentum before collision is equal to total momentum after collision. Here m1 is equal to 100 gram. We convert it into kilogram, will be 0.1 kilogram and it will be at 0.2 kilogram. Initial velocity also given here. So total momentum before collision, we consider it m1 v1 plus m2 v2 is equal to m1 v3 plus m2 v4. First object move at the velocity of 1.67. The putting the value here, m1 is 1 kg, 0.1 into v1 is given 2 meter per second plus m2 is given 0.2 kilogram and v2 is equal to 1 meter per second is equal to m1 is same 0.1 and v3. After the collision, the velocity of first block is 1.67. So v3 is 1.67. m2 is mass of second block is 0.2 and velocity will be v4. That we have to find out. 2 1 is 2, 0.2 plus 2 1 is 2, 0.2 is equal to multiplied by, when we multiply 1 by 0.167 plus 0.2 v4. We add here 2.2, so 0.167 plus 0.2 v4 is equal to 0.2 plus 0.2 it will be 0.4. 0.2 V4 is equal to 0.4. The transfer other side 0.167, it will be negative 1, sorry, 0.167. We subtract 0 0.167 from 4.4, it will be 3 here, 3 also, and here 3 minus 1 2, 0.233. 0.2 V4 is equal to 0.233. V4 is equal to 0.233 upon 0.2. Remove 1.21 place, it will be here, and divide this again. 2 1 the 2 point, 2 1 the 2, 2 6 the 12, 2 5 the 10. So V4 is equal to 1.165 meters per second. It is the result by which the second block or second object will travel with this velocity. In this step, we solve the question number second. If you have any queries, you can write it in comment box. We solve next question, question number 3. It is saying this. In the third question, it is given that two persons managed to push a motor car of mass 1200 kg at a uniform velocity along a level road. The same motor car can be pushed by 3 persons to produce an acceleration of 0.2 meter per second. With what force does each person push the motor car? So given value is mass of motor car m equal to 1200 kg. Uniform velocity along a level road. When the velocity is uniformly, it is not accelerated. When the velocity is uniformly, it means initial velocity and final velocity is same, because we know that a equal to acceleration is equal to v minus u upon t. In this situation, the velocity v1 is equal to v is equal to u. So a equal to v minus v. Initial velocity or final velocity is same. Final velocity also u upon t. Acceleration is equal to 0 in this condition. When the object travel by uniform velocity, its acceleration is 0. In the first position, two men pushes the car with uniform velocity. It means the acceleration is 0. But in next position, when third person came and pushes the same motor car, and it gained the velocity of 0.2 meter per second acceleration. Sorry, these person to produce an acceleration of 0.2 meter per second square. The unit is 0.2 meter per second. With what force each person pushed the motor car? The force is same in this question of each person. So we write acceleration A equal to 0.2 meter per second when third person also pushes the motor car, it accelerates and acceleration is 0.2 meter per second. What does each person push the motor? We know that F equal to ma. So mass is 1200 and acceleration 0.2 meter per second. It will be 12 to the 24 decimal. F equal to 248. It will be our answer, because when two person push the motor car, it is not accelerated. But when the third person came and pushed with to first person, it gained the accelerate at 0.2 meter per second. It means the acceleration is, it means the third person only accelerate the car, because the two person in two person travel the car with uniform motion, but third person accelerate the car. So it is simple question we have to solve. So because all three persons pushing equally apply equal force, hence each person push by 240 Newton force. Next question, question number 4. It is saying a hammer of the mass 500 gram. Mass of hammer m equal to 500 gram and 0.5 kilogram. Moving with the at the velocity v is equal to 0.50 meter per second. Strike a nail, the nail stops the hammer in very short time. Strike the hammer and nail stop the hammer in a very short time. T is equal to 0. T equal to 0.01 second. So it is initial velocity of the hammer. V is equal to 0. because hammer stops down. Hammer is stopped. In the final position, hammer is stopped. Nail stop the hammer. When hammer is stopped, the final velocity is 0 in this situation. From the first equation of motion, we know V equal to ut plus u plus 80. U plus 80. Final velocity is 0 equal to initial velocity is 50 meter per second plus acceleration we have to find, and time is 0.01. We solve it. 0.01 a equal to, multiply by it will be negative minus 50. A equal to minus 50 upon 0.01. We remove decimal from two places. A will be minus 500, 2 zeros, meter per second square. The acceleration, negative acceleration, very high. It is 500 meter per second square. What we have to find the force on the nail of hammer. From the second law of motion, F equal to m. Mass is given 0.5 into acceleration is minus 5,000. From 0 we remove decimal from here, and 5,025, it will be negative 20 meter. Hence the result is minus 2500 Newton. The force of nail on the hammer, the nail will force on the hammer will be minus 2500 Newton. It is our solution. In next question number 5 is saying this. A motor car of mass 1200 kg. A motor car of mass 1200 kg is moving along a straight line with a uniform velocity of 90 km per hour. Its velocity is slowed down to 18 km per hour in 4 seconds by an unbalanced external force. The motor car of mass m equal to there given m equal to 1200 kg. Initial velocity is u equal to 90 km per hour. We convert it in meter per second. 90 into 5.80. 18 5 is the 90. 5,025 meter per second. And final velocity v equal to 18 km per hour. 18 into 5 by 18. 18 1 is 5 meter per second. And slow down by 4 seconds. Time is given here t equal to 4 seconds. we find out the acceleration. Calculate the acceleration. First is given here to find out the acceleration. Given that the acceleration a equal to v minus u upon t. Putting the value, v is 5 minus u is 25 upon t is 4. So it is minus 20 upon 4, 4 5 is 20 minus 5. Acceleration is equal to minus 5 meter per second square. It is the first solution of this question. Minus 5 meter per second square. Again in this question, next, change in momentum. What is the momentum? Second part is change in momentum. Change in momentum. We know that change in momentum to m v minus change in momentum equal to m v minus mu. We put the values. We look here, mass is common, so m equal to v minus u. Mass is 1200 and velocity, initial velocity, the final velocity 5 meter per second minus initial velocity 25 meter per second. So 1200, 25 minus 5 minus 20. 12 to the 24, it will be negative. 12 to the 24, 1, 2, 3. 30. Momentum. The unit of momentum, kilogram, because it is kilogram, mass is kilogram, and velocity is meter per second. Meter per second. So the unit of momentum is kilogram meter per second. In the third point, we have to find magnitude of the force required. We know that F equal to ma. Third point is force, F equal to ma. Mass is 1200 and acceleration is minus 5. 12 5 is 60. 2 zeros, negative minus 600 Newton. Negative. It means motor car force required. Force required. With a uniform velocity of 90 km per hour, its velocity is slowed down to 80 km per hour in 4 seconds. Y an unbalanced extreme force. Calculate the acceleration, change in momentum, calculate the magnitude of the force required. It is 600 Newton force. So we need 600 Newton force, 6000 Newton force to slow down the motor car. So in this way we solve here 3 questions. We solve next question in the next videos. Thank you for watching. धन्यवाद.